Rudy.
I'm Kokil.
I'm Rachel.
I'm Jareen.
My name is Yue.
And we are Swamp Blues Consulting, and we will be discussing today on whether or not the development of a natural gas liquefaction facility is a viable option for the Quaintville area. Before we begin, we'd like to thank Mayor Middle as well as the rest of the council for considering our firm on consultation of the design of this project. What our aim was to do during this process was to determine whether or not the NGL facility is both a responsible as well as a socially responsible option for the town, and also if it can be done in an economically feasible means. If it can be established, how can it be established in such a way that it is sustainable?
So the area of interest includes a landfill with former warehouse and shop and former docks. So after evaluating the area, we arrived at these areas of concern, which include the laws, the power, the air quality, and the soil and the groundwater.
So what we did is we posed these concerns against a predetermined set of evaluation criteria and came up with 3 approaches. The first one is to deny approval. Unfortunately, this isn't a very economically favorable solution for anyone. The second is to approve the facility and to add the best available control technologies. Now, this is both environmentally sound and also economically favorable. However, since we are not powering our energy on site, we don't have control, and thus we might go over the federal Class 1 standards. The final solution is, of course, to approve the facility and generate the power on site. This allows us to control the emissions, is economically favorable, and it is environmentally sound.
Our recommendation for this town is the third option, which is the power on-site option. So as you can see on our design, we propose on using a phytoremediation field to take care of the soil and the groundwater, an algae bioreactor, as well as a facility visitor center. Thus, we want to give Quaintville its very own pristine green and oxygen machine.
So first, we address the permit. It's very important to get a permit before we build a facility. So the first will be the lead agency to prepare environmental impact statement. Army Corps of Engineers, Department of Engineering, Department of Transportation, Fish and Wildlife Service, and Coast Guard agency will participate the NEPA review as cooperating agency. And from initial permit application review to record of decision, need to take at least 2 to 3 years to complete. After that, the involved federal, state, and local agency will announce the permit to the facility.
So the next area of concern is power for the facility. So in the town of Quaintville, currently they have a coal generating power plant. So if we were to provide power for this facility from off-site, we assume that we would tap into this source, and we would eventually go over the federal Class 1 standard. So with that said, we decide on using natural gas. And as you can see with the table, natural gas produces less pollutants than coal, and hence making it a cleaner form of energy. And if we decide to power our facility on site, then we maximize power generation efficiency, and then we have more control over the emission properties from our facility. Hence, we decided to use on-site power with natural gas for our power generation.
For the air quality control, we need to obtain PSD permit, and after evaluation, the pollutants emission which provided by the problem statement, and we found NOx and CO exceeds the regulated threshold. Therefore, we recommend to install the best available control technology, and also we need to notify the land federal manager that the site is within 20 miles away from the federal Class 1 area, and also we need to conduct required assessment to meet federal Class 1 area requirement. In terms of technology selection, we will follow the BACT review protocol, and for NOx control, we select selective catalytic reduction. For the CO control, we select post-combustion catalytic oxidation control. So in this way, we can address the ozone concern as well as meet the federal Class 1 air quality standard.
Unfortunately, these control technologies did not address the issue of carbon dioxide emissions. So after reviewing a number of carbon dioxide sequestration and negating options, we decided to go with the most EPA favorable means, which is increasing the efficiency of the plant. We will be doing this by using an air-to-air heat exchanger, as well as a technique called enhanced coal bed methane recovery, which essentially allows us to take the CO2, inject it into a field of interest, and then pressurizing the ground and then pushing the methane out through another injection well. Another option we considered for the benefit of refuel is to use the CO2 to create a biofuel. We will be injecting the CO2 as well as other effluents in our stream and the wastewater into a bioreactor, which will help spark the growth of algae, and thus allowing us using a fermentation process to create a biofuel. The reason we chose algae is because it's the most efficient when it comes to sequestering CO2, as well as the most efficient when it comes to creating biofuels. 1 acre can create up to 5,000 gallons. Now, using a vertical system, we can bump this up to 50,000 gallons. And by going even further to maximize the efficiency, we can, using a 75-foot wall and 1 acre, we can produce 250,000 gallons of biofuel, which can be used in both transport and as well as supplementary energy inside the system.
So another area of concern we had was with the soil and the groundwater. So as we know, there is a landfill which is on site, and we are assuming that the landfill has been there for at least 20 years. So there's bound to be some leaching and some soil and water contamination. So we recommend the use of dig and haul, where we completely remove the soil from the area. As well as for the groundwater, we have two recommendations. As a short-term remediation, we use the pump and treat, and as a long-term, we propose on using phytoremediation.
So one aspect of the facility we have yet to discuss is the Facility Visitor Center. What this facility will be used as is a means for refuel to demonstrate to the community that they are in fact using clean technology and green technology. In partnering with local talent, they can show how the green technology is being utilized in an aesthetically pleasing way. Also, since it is by the coastline, we will be utilizing the coastline as well as the phytoremediation field, which is essentially a forest, to promote outdoor activities as well as family fun, which will attract both tourism and the locals. Now, a very important aspect is job creation, everybody's favorite topic. During construction, which can take up to 5 years, the size of our facility will require about 5,600 workers at peak level. Obviously, the construction phase ebbs and goes, but we will still maintain at least 2,100 jobs at all times during the construction phase. Now, when the actual facility is running for up to 20 years, we can produce up to 176 jobs for both locals and professionals. In establishing such a facility, there's both non-governmental organizations and concern from the locals, and as well there should be, because if there wasn't, more accidents like this would happen. As some of you know, yesterday the hurricane caused 2 tanks to leak into the local estuary, having 2,000 gallons of gasoline and 5,000 gallons of diesel fuel to leak into the local estuary. And this is a problem because it can affect both the local ecology as well as the commercial oyster bed downstream from the facility.
So because of this, we need to immediately clean up this problem using a semi-permeable barrier, as well as using skimmer, which will take approximately just 2 days to clean up the entire area. Also, the best solution is prevention, and obviously we do not want such a disaster to occur again. We would propose on pulling back the tanks from the location.
So because of this oil spill, we have implemented prevention control measures into our design. After factoring maintenance and transportation costs, so after factoring construction and maintenance cost and transportation costs into our design, we have recovery of our investment can be achieved in 5.5 years. And however, because of the biofuel that we proposed on site, we can reduce this time recovery of capital investment up to 25 years faster.
So in conclusion, our Swan Blue consulting recommend a environmental friendly, social responsible, and economical feasible final design, and the NGL facility and the environment can coexist.
We'd like to thank Dr. Delfino, Dr. Wu, Henderson, Townsend, Stein, and Angelina for helping us with this project, and we'd like to thank AWMA for sponsoring our design. Questions?